Hi students, today we are going to see one of the topics of crystal defect, that is impurity defect. So come, let's understand what is impurity defect. All substances in nature are impure, that we already know that in nature substances are always contain some impurity in them. So whenever we require pure substances for analytical purposes, example a reagent in the laboratory, analytical reagent, so we need very high grade purity, 99.9% purity and all. So for that we need to purify. A number of steps of purification is required. So all these indicate the presence of impurities in substances, that is foreign atoms and ions which originally do not belong to that particular substance is found in crystals. So such a defect is called impurity defect. So what is an impurity defect? It is a defect which is caused due to presence of foreign atoms or ions, or that is atoms or ions which do not originally belong to that substance. So such an impurity is what is impurity defect. Now sodium chloride, example a sodium chloride crystal usually contains, you can see sodium ions and chloride ions, each sodium ion surrounded by chloride ions and each chloride ion surrounded by sodium ions and all. Now if this substance has an impurity such as strontium, here there is an strontium ion and it causes a vacancy here. So this is an example of impurity defect. Now let's see more details about that. So when molten sodium chloride, you have molten sodium chloride containing small quantities of strontium chloride. Sodium chloride is NaCl, strontium chloride is SrCl2. Now what happens is these strontium ions are divalent, Sr++, it has got a double positive charge, whereas sodium has a single positive charge, Na+. So when a small quantity of strontium chloride is present in sodium chloride, what happens is each strontium ion will displace two Na+ ions, two sodium ions. One strontium ion is equivalent to two sodium ions. So two sodium ions will be displaced from the crystal. So this can cause a void or a vacancy in the crystal. You see this crystal here, a strontium ion has come. Originally there was a sodium ion here. When the strontium ion came inside, what happens is the sodium ion present here is sent out, it has gone out. At the same time, because it is double positive, it will displace one more sodium ion. So there was a sodium ion here already originally, but it has been now displaced, it has gone out. So because it is double positive, two positive charges of strontium equalizes that two sodium ions, because each one has only one positive ion. So what happens is this vacancy is occupied by strontium ion, whereas this one is not occupied by any. So it creates a void or a vacancy is created. So this is a kind of impurity defect. So the crystal has a defect now, there is a vacancy. Even though this is occupied, this one is a vacant. Now how many vacancies are created? Each strontium ion will create one vacancy. Example, you see when one strontium ion comes in, it displaces two sodium ions. One sodium ion has gone and one from here also has gone. So two sodium ions have gone, but one of the vacancies is occupied by the strontium, but the other vacancy is not occupied, it is unoccupied, so it remains vacant. So this can cause a void. In other words, the number of vacancies created is equal to number of strontium ions. One strontium ion comes in, one vacancy created. One of the vacancies is occupied, so only one vacancy created. So this is called an impurity defect, which is very common in sodium chloride. And other examples are cadmium chloride, CdCl2, and AgCl is another one, silver chloride. Now one thing important to understand is it does not affect the stoichiometry of the solid, because it is the charges are matching and the ratio is all same, so it does not affect the stoichiometry of the solid. So I think you understood this. Now students, you can see this video once again if you want to understand better, and I request you subscribe this and write some comments what you feel about this, if you understood or not. So that is it. Thank you.